All right, today what we're going to be talking about is similarity transformations. So in the past we've talked about what a transformation is. For example, rotating, symmetry, reflection, all those things. But today we're actually going to talk about something called dilation. Dilation is a transformation in which a figure and its image are similar. And yesterday we learned all about similar figures, so this should make a lot of sense. All right, so we have an enlargement we can do or reduction. Let's say that this black figure right here is our original. This red figure has, as you saw just a second ago, it's gotten bigger and now it's getting smaller. All right, so along with a scale factor, we actually have something called, or along with the dilation, excuse me, we have something called a scale factor. A scale factor is the number you multiply by. So the rule of a dilation with a scale factor of n, or an unknown number, okay, would be if we had an x, let's say we had 2, then we would multiply 2 by whatever my scale factor is, whether it be 1/3, 2, 5, whatever, okay? And you have to multiply both the coordinates by the given scale factor. You have to do both x and y. You can't just choose one. All right, so to find the scale factor of a figure, choose a pair of corresponding sides and use the ratio new over original. All right, in your book, they also say image over original. Um, Either way is correct. It's just however you want to use it. They have this good acronym here, KNOW, so you can remember new over original. All right, which makes it very easy to remember. All right, so otherwise, let's take all this information, let's apply it to an example so it becomes more clear for you. All right, so we have this example. It says, give the coordinates of the image of a triangle ABC with vertices 12, 9, 12, 6, and 18, 9 after the dilation of a scale factor of 2 or a scale factor of 1/3. So what we're doing here is we're actually taking, okay, if I were to graph this particular image, or this particular shape, the triangle, with A, B, and C as its vertices, what we're doing is we're talking about a scale factor of 2, all right? So the first one is a scale factor of 2. Okay, so what we're going to do is we're going to actually watch here. So if I have A, and I have 12, 9. So just like it said before, up top it says I have to multiply both the x and the y by the scale factor, in this case 2. So my image of A will be 12 times 2, which is 24, and 9 times 2, which is 18. All right, so then with B, okay, we would get, let's just do the image of B would be 12 times 2, which is again 24, 6 times 2, which is in this case 12. All right, and then my image of C, which would be 18 times 2, which we know is 36. 9 times 2, which is 18. Now what this is doing now is I'm creating new vertices for my image. So if I were to take this and graph it on a coordinate plane, okay, one thing you would probably notice by the numbers, they're getting larger in this particular example because our scale factor is 2. So our image is getting bigger, all right? It's enlarging. Okay, so what would you guess would happen with a scale factor of 1/3? If you thought it would get smaller, you're correct. It would actually reduce in size. All right, it would get smaller. So what I want you to do is figure out the scale factor, figure out the image of the triangle with the scale factor of 1/3. Do number 2 here. All right, and I'll look for it in your whisk tomorrow. Okay, so to continue with those dilations, with this idea, we have an original. So I have this great frog here, okay? And this frog has a scale factor of 1. It's the original, okay? But a reduction, okay, is a dilation with a scale factor less than 1, as demonstrated earlier by our other example. Okay, so it's smaller. Our little frog got smaller. On the other side, an enlargement is a dilation with a scale factor greater than 1. So for example, a scale factor of 2, which means that this guy right here is double the size of this guy, whereas this guy is half the size of this guy. All right? Okay, so let's do an example here. Okay, so I have draw a dilated image of a triangle with vertices 0, 1, negative 1, 1, and 1, negative 1, and represent the origin O with respect to the origin O with a scale factor of 3. So I need to take my coordinate planes and I actually need to write out my images. So I'm going to multiply 0 times 3, which is 0, 1 times 3, which is 3, find the image of B, and that would be negative 1 times 3, which is negative 3, and again negative 1 times 3, which is again negative 3. And last vertice, we have the image of C. So I'm going to do 1 times 3, which is 3, and negative 1 times 3, which is negative 3. From here, what I can do is if I were to graph my original triangle, so let's say I have 0, 1, I'm going to do it in blue. I have negative 1, negative 1, and I have 1, negative 1. So as you can see, we have this triangle here. All right, now I'm going to do the dilation or the enlargement of the new things, of the new image. So I have 0, 3, negative 3, negative 3, and 3, negative 3. So my triangle got bigger, but just like the definition says, the red figure or the image is similar to the original triangle. They are similar. All right, so let's see how well my graph turned out. There we go. A little easier to see. All right. Then on the other side, we have a reduction. So in this case, we're multiplying by 1/4 because it says draw the dilated image of the rectangle with respect to 0 with a scale factor, or with respect to the origin, excuse me, with a scale factor of 1/4. All right, so I'm going to figure this out again. I'm going to do um, my image of A. Well, 0 times 1/4 is 0. 0 times 1/4 is again 0. My image of B. So I have 4 times 1/4, which is actually going to be 1, and 0 times 1/4, which is going to be 0. My image of C, which is 4 times 1/4, which is 1, and again 4 times 1/4, which is again 1. Find my image of D, 0 times 1/4. I think you get the hang of it now. Go through, graph these points, and there you have it. Our original figure, which is our big green one, and it has been reduced to a tiny rectangle that is similar to the original rectangle. All right, so that's all I have for you today about dilations and scale factors. Please remember that formula, how to solve them, this just say no formula, as well as how to graph and solve using the scale factors. If you have any questions, please bring them in or into class and write them down in your WISC. We will go over this tomorrow. Otherwise, please make sure that you are in fact watching this video all the way to the end. If you have watched it all the way to the end, I would like you to draw me a picture of the Olympic rings in honor of the Olympics coming up soon. All right, thank you.